Hi everyone. Today we'll be discussing the lead code problem of the day, maximum total damage with spell casting. So here you have a magician that has various spells. You are given an array power where each element represents the damage of the spell. And it is given that multiple spells can have the same damage value. And it is known that if a magician decides to cast a spell with damage power I, then he cannot cast any spell with the damage of power -2 or -1 or +1 or +2. So that means suppose if the magician has casted a spell of power 5, then he can't cast of 4, he can't cast a spell of power 3, or he can't cast spell with power 6 or spell with power 7. So -2, -1, +1, +2. So if he casts 5, then all these spells he can't cast. And out of the array, each spell can be cast only once, and you just have to return the maximum possible total damage that the magician can cast. So if we check the first input, we have 1, 1, 3, and 4. Suppose if we choose to cast the spell 3, then because of this, we can't cast any of these. We can't cast 1, we can't cast 2, 4, and 5. So we can't cast any of these. So if you put a spell of 3, damage 3, then the 1 and 4 are ruled out. So the answer is only 3. But what if we don't cast the spell 3 and we choose to cast the spell 1? So we are casting 1. So because of this, 2, 3, 0, -1 are ruled out. Let's just check the constraints. Yeah, so the power is only positive. So we can just ignore these ones. So now, because we have chosen the spell 1, we can't cast spell 2 and spell 3. So this is ruled out. So we can again cast spell 4. So we are casting spell 1 and we are also casting spell 4. And since 1 is present 2 times, so we can cast the same spell twice. So total damage will be 6. 4 plus 1 plus 1. So the answer is 6. Now for the second input, if we choose to cast spell numbers, spell 7, then we can also cast spell 1. But we can't cast spell 6 because since we are casting 7, 7 minus 1, 6 is ruled out. So total damage is 8. But what if we choose to not cast spell 7 and instead of that we want to cast spell 6? So in that case, answer will be 1 plus 6 plus 6 equal to 13. So in the second input, the maximum output you can generate is 13. Now let's go over the approach. So one thing is clear that if we are picking a spell of damage X, then we will choose all the occurrences of X from the array. So in this example also since we are if we are picking the spell with damage 1, we are picking all the ones available. So here the answer is 1 plus 1 plus 4, 6. And similarly here, since we are picking a 6 in our answer, we will pick all the 6 available. So answer will be 6 plus 6 plus 1. Because in the constraints, he says that if you cast a magic with damage of power I, then only these values are restricted. So the power I is not restricted. So you can pick this any number of times as long as it is present in the array that many number of times. So that's clear. Now let me take an example. So we have this array, and for this the answer should be 31. So I've just extracted all the unique values from this array in sorted order. So it will be 2, 3, 5, 7, 8, 9, 10. Let me also write the index. So to solve this, we can use a dp array. So dp of I will denote max damage using this elements from index 0 to index I. So if we have dp of I equal to max damage using elements from index 0 to index I, so if we compute the dp table, the dp array, so in the last entry, dp of n minus 1 will denote the maximum damage using all these elements. So this will be our final answer. So let's see how we will fill this dp table. So initially what we have is the starting element dp of 0 will directly be the frequency of this 2 times the value. So from this we can see 2 is present 2 times, so dp of 0 will be 4. So that means if we have only up to this element, the answer will be 4. 4 because 2 is present 2 times, so answer is 4. Now for further values, for this value we have two choices. One choice is either we can pick this 3 or we can not pick 3. So directly we can say that dp of I equal to maximum of dp of I minus 1 or just the number of I into frequency. Put it here. So this term indicates that you are not picking this element, so you're getting answer just from the previous value. And this term indicates that you're ignoring every value taken so far, and you're only taking the current value, and how many ever times it's present, you'll take it that many times. So based on this, we can see that for this the answer will be maximum if we don't pick the 3, because 3 is present only one time. So if you pick the 3, it will only contribute to 3. So if we choose to not pick 3, then our answer will be 4. So dp of 1 will be 4. So this indicates that out of these two values, what is the maximum damage I can form? So maximum damage you can form is 4 by taking this two times. After this, I'd also like to discuss one thing. So suppose we are looking at here, we are trying to fill the value at this position. So again, the same thing, we'll first try to get the answer using this formula, dp of I minus 1. So you'll check the answer here and you will compare it with just by picking the 8. So whatever is the max, you will put the answer. So after doing this, you can also take this 8 and the previous values as well. So that means what I mean to say is, if you pick 8, then you can't and you try to check I minus 1 value, and you see that the value is 7. So since you picked 8, according to this, 7, 6, 9 and 10, all these values are ruled out. So when you pick 8, you go and check I minus 1 value. It is 7, it is ruled out, so you don't pick it. And you try to go to I minus 2 and you see it is 5. So 5 is not ruled out. So what you do is, you can also pick this value. That means dp of I equal to max of dp of I comma dp of I minus 2 plus frequency. So initially what you do is, this indicates that you are not picking the current number and you will get the answer only from the previous value. And this indicates that you will ignore every previous value and you will only pick the current value. After doing this, there's also a case where you will pick the current value along with some of the previous values. So for that, we check this. First, we check with I minus 1. If the I minus 1 is safe to pick, then we will just do max of dp of I comma dp of I minus 1 into the current value. If I minus 1 is not safe, we go and check I minus 2. So since in this example I minus 2 is safe, so we pick it. If I minus 2 is also not safe, then finally we go and check I minus 3. And if I minus 3, so I minus 3 will obviously be safe, because since we only have unique values. So if we have 8 as current value, so the previous value can be 7. So I minus 1 can be 7 and I minus 2 can be 6. But we see that I minus 3 should be minimum 5. I mean, max it can be 5. So if I minus 1 and I minus 2 are not possible, then I minus 3 will be possible for sure. So once we calculate either I minus 1, I minus 2, I minus 3, whatever is available to take, we also check this formula. So yeah, let's just continue our dry run. So yeah, we are at this index, and by this formula, we just got the value of 4. Now we'll also check the case where I want to pick 3, and I also want to check the I minus 1th value, if I can pick this 2 or not. So because I'm picking 3, both 2 and 1 are ruled out, so I can't pick 2. So I minus 1 is failing, so I try to check I minus 2, and since I minus 2 is going out of bound, I stop. So the answer is 4 for dp of 1. Now let's see for the next index. So for this, using this formula, either we can use the previous value or we can take the current value. So if we take the current value, then we will get the damage as 5. And if we take the previous value, we get the damage as 4. So 5 is greater than 4. So that means picking 5 is the good choice. So once we picked 5, we'll also check whether we can pick any of the previous values. So we'll first check I minus 1. So we can see 3, since the current value is 5, so 3 is also blacklisted. 3 is also ruled out, so we can't pick 3. So then you try to find I minus 2. So you picked 5, and I minus 2 value is 2. So 2 is not ruled out, so you can pick 4 as well. So the answer will be the current value plus dp of this I minus 2, which is 9. So this means that in this first 3 elements, your answer will be 9. That is by taking 2 plus 2 plus 5. This is how you'll get 9. So let's move on to the next index. For this, if I choose to pick 7, I'll get the value of 7. If I don't choose to pick 7 and just go by the previous value, I'll get 9. So far the value is 9. Now after this, I try to see whether if I can pick any of the previous values along with the 7. So first I check I minus 1. So it is 7 minus 2, 5. So 5 is also ruled out. So I try to check I minus 2. So 3 is available. So the maximum value will be 7 plus dp of this value. It's 11. So I'll update the value to be 11. Now let's go to this index. So again, I'll check the previous value, which is 11, and the current value. Yeah, the current value is 8. So out of 8 and 11, 11 is maximum. So currently the answer is 11. So now again, I want to check whether if I take 8, what else in the previous values I can pick. So first I'll check I minus 1. So 7 is also ruled out. Then I'll try to check I minus 2. So 5 is available because 8 minus 5 is greater than 3. So 5 is available. So what I can do is I can get this deep value 9 and also take this 8. So the answer will be 9 plus 8, 17. And let's move on to the next index. This. So here, if I want to pick this 9, if I only want to pick this 9, my damage will be 18. 18 because 9 is present 2 times in the array. So if I pick this 9, if I only pick this 9, I'll get the damage as 18. And if I don't pick this 9, I'll get the damage as the 17, which is from the previous values. So we can see that 18 is greater than 17. So currently our answer will be 18. And now again, I'll check what all the previous values I can pick. So I minus 1 is 8, so I can't pick it. So I minus 1 I can't pick. I'll go and check I minus 2. So here we can see that I minus 2 also we can't pick because we are picking 9, 7 is also ruled out. So finally, we go and check I minus 3. So for I minus 3, the value is 9 and the current value is 18. So if you pick 9, we'll get the sum as 18. So 18 plus 9, we get an overall 27. And finally, let's go to the last index, 6. Not 6, 10. So from the table, we can see 10 is also repeating 2 times. So if I want to pick 10, my damage will be 20. And if I don't pick this 10, my damage from the previous values will be 27. Out of these both, 27 is the maximum. Now I'll also check if I take 10, what all the previous values I can pick. So similarly, check I minus 1, 9, so it's ruled out. Now check I minus 2, 8, so it is also ruled out. So finally check I minus 3. So I minus 3 is available. So I minus 3 you can pick it and its value is 11. So 11 plus 10 plus 10. So 11 plus 20, it is 31. So in the last value, you will have 31. So once the DB table is computed, you will just return the last value, which is 31. So for this input, the answer is 31. So to solve this, you'll first create a hash map, which will store what is the frequency of all these elements. And then you'll extract only the unique values, you'll sort it. And on this, you'll run this algorithm to fill the DP table. So this is the DP table. And once this is filled, you'll just return the last value. Now let's quickly code the approach. So first I'll start by sorting the array. And then I'll just create a hash map. And also a list which will have the unique values. Let me just iterate on the power array. And update, first of all, let's update the frequency map. So map dot put nums map dot get or default nums comma 0 is 1. So initially, while we update the frequency, it is just like this. So map dot put nums and then map dot get nums plus 1. So the old frequency plus 1. So what if we are doing it for the first time? So the first time nums is not present in the hash map. So in that case, we use get or default. So if it's not present, it will return 0. So for the first time, it is 0 plus 1. So the first time the values will be 1. And once we are updating our frequency, let's also add the number in the unique if it's not already added. So for that, we can check like if unique dot get not equal to nums. So if the last element in the unique list is not equal to the current number, that means we are on this number for the first time. So we'll add it in our list. Unique dot add nums. Also, when I equal to 0, we need to add for the first time. If I equal to 0 or the last element of the unique is not equal to nums, we add it. So once this is done, we'll get the size of the new unique array. Size. And let's create a DP table, DP array. So here we are using long because the power can be at max 10 power 9 and the number of the array size is 10 power 5. So the maximum power it can go is up to 10 power 14. So that's why we are taking long for the DP table. Now let's just fill the first value. So DP of 0 will be simply picking the first element, so which is unique of unique dot get 0. And this value can be present multiple times. So we'll just multiply it with the frequency. Map dot get unique dot get of 0. So the 0th index is filled, and let's start from the first index. So we get the damage. So the first step is first we have two choices. Either we cannot pick the damage, so that will give us dp of I equal to dp of I minus 1. So dp of I minus 1 denotes we are not picking the current magic. And if we only pick the current one, our value will be damage into the frequency. So initially we have these two so far, and now we also want to check the case where we will pick the current value and also some of the previous values. So for that, let's just check I minus 1, I minus 2, and I minus 3. So if unique dot get I minus 1 minus unique dot get, okay, this will be I. So if the current value minus the previous value is greater than 2, then only we can pick it. Because if the current value is power of I, then we can't pick power of I minus 1 and power of I minus 2. So the difference should be at least greater than 2. So if it's greater than 2, we'll just check the DP condition again. Math.max DP of I, comma. So we can pick DP of I minus 1 plus whatever the value we we have by picking the current value. Damage plus map.get damage. So if we are not able to pick this, then we try for I-2. And while we do for I-2, I-2 can also go out of the array. So first we check that I-2 greater than equal to 0. And the difference should be greater than 2. Then we can pick the I-2 value. We can just write else if. And the last condition is even this is also not satisfying. That means even for I-2 is also blacklisted. Then finally we go and try for I-3. And this time we are sure that the I-3 will be greater than 2. So we can just ignore this condition. We'll just put the condition check where it is not going out of bound, and we'll just update the value. So we'll pick the value from dp of I-3 and add it to our current selection. And once this is done, we can just return dp of n-1. Okay, this is arrays.sort. And what now? Okay, since I'm iterating it like this, so for this what I can do is unique dot size equal to 0. So if it's empty, initially if it's empty, you just add the first element. If it's not empty, then just check if the last element is not equal to the current element. Okay. Yeah, it passes. Let me submit. Okay, it's failing for large cases, so I think there's an overflow. Yeah. So here we can see that we are multiplying damage with the frequency. So both damage and frequency are integers. So when you multiply, this value will overflow. And that overflown value, we are storing it in our dp table. Even though dp is long, but when you do the multiplication, the value overflows, and that garbage value will be stored in this. So to prevent this, we can typecast any one of this to long. So we can just take the frequency in long. So this will help it. So now since the frequency is long, this term is long. So the multiplication will be done in the long and it won't overflow. So same for this as well. Let's run it. Let me submit. Yeah, it works. Finally, let's do the time and space complexity analysis. So for the time complexity, we have we are sorting the array. So this will be NlogN. And after that, we're just putting the elements in the hash map. So this is order of n. So NlogN, order of n. And here, this loop is running n times. And in that we have like 3 operations. So this is constant. So this loop's total complexity is n. So the overall, the sorting complexity is dominating. So we have the total complexity of NlogN. And coming to the space complexity, since we are creating a hash map, we are creating a unique list. So this is of size n. This can be up to size n. This also size n. And also the dp of size n. So overall, the complex will be order of n. And I also have the code in Python if anyone wants to view it. And I'll add it in the description as well. Let's catch up in the next video.